All right, so 16.1 is quadratic equations, the square root method. All right, so you're going to have questions that kind of look like this. Actually, this is a review question on how to do it by factoring. So we'll get to the square root here in a second. So as a review, if you recall from, is that chapter 14? No, 13. It's chapter 13. When solving quadratics, you always want to set it equal to 0. So I got to move this minus or negative 16 over by doing the opposite. So if this is a negative 16, I have to add 16. That will make this 0, which is what I wanted. I cannot actually combine any of these, so I'm going to write it as is. So x squared minus 10x plus 16. Now I'm ready to factor. So remember, we do a little t-chart. We are multiplying to our c. Remember, it goes A, B, C. So I'm multiplying the 16. I'm going to add to my B, which is negative 10. Now, on this one, I only pay attention to the numbers. I don't bring in the x's. So now I got to come up with two numbers that will multiply to 16, but add to negative 10. Two times 8, perfect. So we get 2 times 8, which is 16, but how do I make it a negative 10? They would both be negative. Right, but when I multiply them, it'll give me a positive, but when I add them, I'll get a larger negative. So there's two ways to multiply to a positive number. They either both have to be positive or they both can be negative. And determining what your B sign is will determine what these signs are. So since my B sign was a negative, that tells me both of these must be a negative now, because that right there will now add up to negative 10. So negative 2 and negative 8 will start off with 2 times 8 is 16. And then if I make them both negative, then I still get a positive 16 out of it. And if I owe someone $2 and I borrow another 8, now I owe them $10. Mm-hmm. When multiplying, and then because remember, you're doing two things. You're multiplying them and adding them. So when we multiply two negatives to get a positive, that's the first step. And then I add two negatives and it gives me a larger negative. Right. And then from there, a trinomial will factor into two binomials where the leading term will be an x. And then you just write out the factors you just came up with. So minus 2, minus 8. And then from this, I just set each factor equal to 0. So x minus 2 equals 0 and x minus 8 equals 0. That comes from that zero product rule where either a equals 0 or b equals 0. Now I have two linear equations I can solve. So what's the opposite of minus 2? Plus 2. So I get x equals 2. What's the opposite of 8 or minus 8? Positive 8. So I get x equals 8. I think someone said last time they just changed the sign. You could do that as well. But sometimes there's a number in front of the x, so sometimes you get a fraction, so there might be a little bit more to it. But that's good practice there too. And that's it. So that's kind of what we did back in chapter 13. We also saw problems like this, where we had 4x, oh, we'll look at number 2, 4x squared minus 24x equals negative 36. What's my first step? If I could, yes. Good. Combining like terms is a good start if there was some to combine. After that stage, I need to set it equal to 0. So I'm going to move that negative 36 by doing what? Perfect. Trinomial is what they end up being. So quadratic trinomial. Ooh, go with it. Where you going with it? What about it? Perfect. So when factoring, our first question should be, is there a greatest common factor? In this case, 4 would be that greatest common factor. So I'm going to divide all the numbers by 4, including 0. So when I do that, what happens to the 4 here? Cancels out, leaving me with just x squared. What's negative 24 divided by 4? Negative 6. What's 36 divided by 4? Close. 9. Very good. And then what's 0 divided by 4? 0. So again, and the only reason I divided that 4 over there on the right, obviously it's going to stay 0. But anything we do to the right, we have to do, anything we do on the left side, we have to do on the right side. So to keep that practice going, I just want to make sure y'all saw that I wasn't just randomly dividing by a number. I did it to every number. All right. And then from here, we're right back to where we started on question 1. So now I can come over here, figure out I'm multiplying to 9 and adding to negative 6. What would those be? What? Very good. Negative 3 and negative 3. So I give you the positive 9 and the negative 6 that you desire. You write your two factors with the factors you just came up with. And then now you can set those equal to 0. But notice they're exactly the same, so you only have to do it once. So this will just be x minus 3 equals 0. So what do I have to do to solve it? Add the 3. And if you wanted to solve it and get the same answer again, you could, but I can see that these are both going to be the same number, so I only need it once. All right. All right. So now the next type of questions you're going to see are going to look like this, and it's going to be a little bit now of a blend from chapter 15. So x squared plus 25 equals 0. So you could try your factoring technique here, where I can go, all right, I'm trying to multiply to a positive 25, but add to 0. Well, we just talked about the only way to multiply to a positive is if they're both positive or both negative. Well, can you add two positive numbers to get 0? No. Can you add two negative numbers to get 0? Which two? So there is no way if they're both the same sign that we can get 0. If they were opposite signs, then we can say, oh, well, 4, negative 4, 5, negative 5, or something like that. So since it's a positive, I cannot factor this. So then you might go, oh, it's unfactorable, can't solve it, move on with my life, right? But now that you've learned so much from chapter 15, now we can keep this going. So this is a binomial currently, but it's not a trinomial that we saw earlier. So I need to isolate my x before I can solve it. So I'm going to move my positive 25 over by subtracting it. Oop. Now, in chapter 15, we isolated the radical so we could square both sides. This time, we isolated the square so that we can square root both sides. So we're basically doing the opposite of what we did in chapter 15. The only issue is when you take the square root of something, you have a plus or minus. Now, here's the reason why. If let's say X is oh, I haven't finished it. I got distracted. Um, if I have 2 squared, what is that? 4. If I have -2 squared, what is that? It'd be +4 because that'd be -2 times -2. Two negatives actually make a positive. So the reason we do this plus or minus because we actually don't know if the answer is a positive or negative. So anytime you take the square root of something, we'll add a plus or minus to the beginning of our problem. Now we can express this just like we did in chapter 15. When we have a negative, what do we pull out? Not a 1. You have a negative inside of a square root, you pull out a. That's what all that last 2 or 3 sections of chapter 15 was all about. Anytime you have a negative in the square root, you can pull out an I. Oh, I means the square root of -1. So basically what I just did is I went, okay, well, this negative becomes an I. Now I just have a positive. So it's like this. That's what I just did to this problem. I just separated it as a negative over here and 25 over here. And this negative became an I. Now I can just look at the square root of 25. And what's the square root of 25? 5. So now my answer is plus or minus 5i. It's not a real answer, but it's an imaginary answer. Alrighty. So let's keep this going then. Number 4, we have x plus 6 squared equals 12. Now, go ahead. It would be. You'd think about folding it out. And that's a process that we did in chapter 14 or 15, where we would fold it out, combine like terms, then go to factoring. But now there's an easier process. Using this square root method, if my square term is isolated, I can just take the square root of both sides. And we just learned that now. So yes, in previous chapters, we had fold it all out, combine like terms, factor, and go on from there. So now what I can do is the square root and square root cancel. So now left with x plus 6. Well, plus or minus, because anytime you take the square root, you don't want to forget the plus or minus. And then that 12 is not perfect. So I got to do the little tree. So what 2 things multiply to 12? 2 times 6. And then 6 breakdowns into 2 and 3. How many numbers do I need to pull out? 2. So I pull out a 2. And then I have a leftover of what? 3. Mm-hmm. So if they're a group, they have the way I teach it to high schoolers, your parents always tell you if you're going to leave the house, you have to have a buddy with you. So these two have a buddy, so they got to leave the house. So they're no longer in the house, they're outside the house. But this guy did not have a buddy, so he had to stay in the house. It's corny, but some of the high school kids kind of remember it that way. So if I have 2 of the same, they get to come out as one. And then if they didn't have a partner, they had to stay in. Yeah, or wherever, or go to dinner or whatever they're going. I don't know. A little piggy goes to the market or something. I don't know. Whatever you want to do. And then from here, we're quite not done because we haven't solved for x. I still got to get rid of this plus 6. How do I get rid of the plus 6? Make it a minus. Now here's where it gets interesting. I cannot combine any of these because of that square root. So what we do is we write it as we see it. So -6 plus or minus 2 square root of 3 would be your final answer. I know a lot of times your calculator will give you the decimal and the decimal will be right, but your homework's going to want it written like this. All right, let's play around with another one. The number 5. X squared equals -16. What am I going to do? Okay, you could do that to set equal to 0, right? Because that's what we just did at the beginning of this lecture and what we did back in chapter 13. I could add it up there, but then you would try to factor. So let me kind of show you this. So if you did this and you got to this point, it's not a bad step. That's actually probably what I would do, especially when you get your final here on Monday and everything's just blended in together and you're trying to remember, all right, which one do I do first type stuff. This might actually be the step I do because I might forget. I'm going to show you here in a second. But then I get to this stage, and then I hope then at this point I remember, all right, if I'm multiplying to a positive, there's no way I can add to 0 because they would either have to be both positive or both negative. So then I'm like, oh, there was another way. If the square is, if I got my square isolated, I can take the square root of both sides. So that is one thing that makes the final hard is now it's everything you've learned. And now you're trying to remember, all right, do I apply it here? Do I apply it here? Do I apply it here? And then you just, in my honest opinion, just try one and see if it mathematically works. If it does, great, keep going. You're probably on to something. But then if you get stumped, like right here, I got stumped. I need to backtrack going, all right, that wasn't it. And then let's try something else I learned. All right. So then from here, this will cancel. What am I not going to forget? My plus or minus. Don't forget the x too. Yeah. Yes, you do. So I wasn't saying you were no the second time. I was just wanting to show you what happens if you went the route the first time. And then I have a negative, so I'm going to pull out an I. And then now I can pretend this is just positive. So what's the square root of 16? 4. So we get x equals plus or minus 4i. Right? It confuses a lot of kids. And it's really just because they can't wrap their head around. It's like, why are we playing around with imaginary numbers? Like, but there's a reason because we learned that I times I is I squared, which equals -1, which is a real number. So two imaginary numbers multiplied together give us a real number. And you might again go, why did we get this? Well, there was some mathematician in the 1800s that was doing an experiment where when he did, well, he was doing the work. He I don't know, got the process and it should have been able to have been done. So he mathematically did it, and he's like, "Yeah, I don't even get a real answer, but I'm still getting some type of product over here when I take this and I combine it with this over here." And he was really scratching his head. So he's like, "Well, I don't know. I'll just keep the math going with a negative and see what happens." And then he ends up coming. He goes, "Oh, I actually got an answer over here, even though this told me there was no solution," because that's what math had told him prior to. And then he realized, oh, wait, we can actually keep going. So then he tested with a whole bunch of stuff and he goes, oh, there's like an imaginary situation going on here that we just can't put a mathematical finger on. But if we kept it going, we actually get a product over here. That's where it kind of came to be. So it didn't start off with someone was like, hey, I want to play with some imaginary numbers or something. It was like they were really scratching their head going, why are we still getting product on something that should have never been able to produce anything? So, all right. So in our next made up equation here, what is my approach? Yes, they did. So I try to develop my own. They never work out. It's like long decimals, and they're like, okay. Oh, I get it. That's how it was with English. All right. So what's my approach? What do y'all think? Almost. But the key is we have to isolate it. So I need to get rid of this five. How can I get rid of this five? Is it minus? What's the five doing to the problem? It's being multiplied, so I needed to divide. Perfect. So what's 60 divided by 5? Well, now what can I do? Don't forget. And then we can break this up. And then we pull the pair out as one. This guy didn't have a partner, so he stays in the house. Yeah. Right? It's okay. You'll see it enough times in your life in this class and the next. Multiple numbers multiply. And then what would be your last step to solve for x? Correct. But I can't actually physically add them because it's attached to a square root. So I have to keep it like this. If it was just a two, let's say I got the square root of 4 and it gave me 2, then I could actually physically go, all right, what's 5 plus 2? What's 4? I don't know where I just got 5 from. But yeah, I could go 4 plus 2, 4 minus 2. Go ahead. Oh, it just looks cleaner. Technically, you could write it like this, plus or minus 2 square root of 3 plus 4, but that just looks like a lot of pluses. So most no, it's not. No, it's the only plus or minus is the one with the square root or whatever operation I did over here. That 4 is just a positive 4 in this situation. But most mathematicians will put it in the front because it just looks cleaner to have the plus or minus in the middle and not starting out the problem and then having another plus 4 later on in the problem. All right. It wouldn't be a great homework session if we didn't look at word problems. All right. Now, I can usually ask a former high school student, what are the two things that you learned in math class? They'll tell me y equals mx plus b. Couldn't tell me what it means, but they'll tell me that. Can anyone think what the other one they'll remember? Y equals mx plus b. What's typically another one that you have close? A squared plus b squared equals c squared. So that's what we're going to be talking about right now is the Pythagorean, and I never spell it right, so I'm going to look at the book here. Pythagorean theorem. Yeah, this is part of the word problem. So this is going to be a squared plus b squared equals c squared. Now, typically, a lot of students, again, can tell me this, but don't remember what it means. This purpose is to be able to solve for a missing side of a triangle. How's y'all's little tutorial thing going, or whatever it is? Yeah, you got. Hopefully this one. It'd be great if the lab would go over everything you're supposed to go over for the final, not some other new method. Okay. All right. Okay, so number seven, I was just curious to see what kind of math y'all were doing. I know originally y'all were doing geometry or something the first week or something like that. So is it like a lab full of all kinds of math students? Man, it should be like I'm okay with like this lab being shared with like other people in the same course. Like maybe you got, 16 different developmental math courses or something, and you all kind of sporadically come to the lab, but then at least you're all seeing the same thing and not like, you got this class doing this class doing this. That's just seems like, uh, so this is a right triangle and typically used for finding a missing side of a triangle. So in this case, you are told if the hypotenuse is going to be the longest side. So this is your hypotenuse. Hypotenuse. So if the hypotenuse of a right triangle, and this makes it a right triangle because there's a square box to indicate 90 degrees. So this right here just means 90 degrees. All right. It says that it is 26 feet long. So we have 26 feet. And one leg is 24. These are called your legs. Typically, it does not matter. This can be your A, this could be your B, or this could be your A, and this could be your B. The only side that matters is that the hypotenuse has to be C. But how you do your legs does not matter. I guess they go AB or BA, either the same concept. But then it said one of the legs is 24. Totally up to you which leg you want to be 24. Which leg? Yeah, sounds good. That part does not matter. But that now means you're solving for B. So if I would have let B be 24, then I'd be solving for A, but I'm still solving for a missing side. So I'm going to take my information and I'm just going to plug it into this equation. I get 24 squared plus B squared, you could change it to an X if you would like, equals 26 squared. So the first thing I got to do is I got to figure out what these numbers squared are. So what is 24 squared? Sounds about right. What is 26 squared? Sounds good. Now what do you think I would do next to solve for B? Not square root yet, because it's not isolated. You would subtract. Perfect. I got to get rid of it on both sides. Yeah, anything you do on one side, you have to do to the other. Very good. I want to get B squared by itself. I want to get this guy by itself. So anything that's around it, I want to move that over. I wouldn't want to move this one over because then there'd be still a number attached to the B squared. I want B squared by itself. Mhm. 676 minus 576? Did you do 5 minus 6? Other way, because you're subtracting the 576 over. So it'd be 676. Yeah, correct. Right. So B something squared is 100. So what do I do to get rid of that square? There you go. So I'm going to square root. Now we're not going to forget what? plus or minus. And what's the square root of 100? 10. Two numbers that multiply to 100, 10 and 10. You're good? Now, here is the next thing you have to think about when dealing with word problems. This is a measurement of a triangle. Can you have negative measurements? No. So the answer here is actually just going to be positive. A non-word problem, plus or minus. We don't know if it's a positive or negative. Word problem cannot have a negative measurement. So it's going to be the positive answer. Is it someone is that Santa or something? It's like, sounds like someone's walking on the roof. Is it raining again? I just don't know what to wear anymore because like I wake up one morning, it's like 30 degrees. Next day it's like 60s. And I'm like, I don't. Yeah. Mhm. See, okay, I can't deal with this. Pick a temperature in the morning. Let's go with that one. I know, but it's killing me. I'm gonna get sick, and I'm trying to hold off for another week and a half. Oh, I didn't even know there was a room over there, but that makes sense because I guess the okay, that makes sense. All right, number 8, you'll have a question like this where I'll say the dimensional, sorry, my bad. The diagonal of a rectangle. There's a rectangle. Here's a diagonal. Says the diagonal of a rectangle is 3 times the width. All right, well, here's our width. Here's our length. I just call them W and L. So my diagonal, again, it said 3 times the width. So whatever my width is, which I don't know, this will be 3 times that. How would I write that? 3 times the width. How would you write that? Good. 3W. Oh, 3W, or 3 times the width. And then it says the length of the rectangle is 10 inches. Find the width of the rectangle. That's all the information we get. Yes, because the fact that we have the diagonal, in a rectangle has 4 90-degree angles. So technically, we are looking at a triangle inside of a rectangle. Very good. Correct. All right. Sounds good. And remember the formula is a squared plus b squared equals c squared. Oh, what's your b? It's just w. So this would be 10 squared plus w squared equals 3w squared. So yep, so 10 squared is 100. With a 3w. So in the problem, it's going to say something. I said that the diagonal is 3 times the width. So it gave us a statement that we had to turn into an equation. So since I don't know anything about the width, I just called the width w. And I was like, all right, well, if the diagonal is 3 times the width, I can just do 3 times w. So let's say like the width was 4, then I would know the diagonal is 12 because it would be 3 times that. That's how I produced this equation for the diagonal. But the longest side of a triangle, which is opposite of that 90, it always has to be the C. So it's not just 3, it's 3W that's replacing the C. So now I have to take this square and I have to distribute to both. So it would be 9W squared. Correct. So what do I do now? Okay, which one are we moving? You would want to move the W squared because I don't want to have to deal with negatives. So you're always going to move the smaller one over. Technically, this has like a 1 in front of it. So I want to move this one over just so I can avoid negatives. So I'll subtract W squared. Or this will, but what about this? What's 9W squared minus W squared? There it is. Oh, you got way more than normal. You know, this would be kind of cool if I wrote the 9 over here. It could have been W29 or W9. What is it? Nah, that's not something. Yeah, now divide by 8. Sorry, my brain went somewhere else. All right, what is 100 divided by 8 simplify down to? Take your word for it. 12.5. Now what would I do? Square root. Now, I'm not going to forget the plus or minus. However, we're dealing with a word problem where we're dealing with measurement, so that I know my answer will really just be a positive. And in this situation, on your oh no, your I forget your question. You get two of these. One, it wants the exact answer. Then the second one's asking for the decimal. So let me backtrack on this 12.5. What is 100 over 8 simplified as a fraction? 25 over 2. He was ready for it. All right, here we go. So with the fractions, remember I can separate this as the square root of 25 over the square root of 2, and separate as two separate problems. The square root of 25 is what? 5. And I don't know what the square root of 2 is. Because 2 is already a prime number and this is 2. There's nothing I can do. But if you recall from chapter 15, do it. Yeah, square root of 25 is 5. Done. No more square root. But the square root of 2, we can't have radicals on the denominator. So how do I get rid of that square root of 2 on the bottom? What do you mean by that? How do you do that? How do we get the square root from the bottom to the top? All right. This is called rationalizing. You would have to multiply the bottom and top by that square root. And we did that because we learned that two radicals that are exactly the same, the radical goes away and I'm left with the radicand, no longer having a radical on the denominator. And so then on top, it ends up just being 5 square root of 2. So one of your questions asked for this. The other one asked for a decimal version. So what would this be as a decimal? Check that. Mm-hmm. We'll go with 2 places. You said 5, 4? Yeah. So 3, 5. So that 5 will tell that 3 to be a 4. We're just going to go to 2 decimal places. So in your calculator, do make sure that, yeah. Mhm. So depending on what the question's asking, if it wants exact, that's what it is. If it's asking for you to round, well, you don't got to worry about doing all this. You would have got the answer the moment you went from here to here. And that's pretty much all of 16.1. So let's take a 5-minute break and we'll begin 16.2.